So we're now recording, yeah. Oh, hello, Violet. Welcome.
Hi.
Do you have a computer with you?
Unfortunately, no. I just came from dance class and food.
That's all good.
Do we have an extra Sport Dog laptop?
No, you could use.
I don't know.
Could use my computer.
Okay, if you're okay with
I'm fine with that.
If you're okay with that.
So
I trust Violet.
The MacBook.
mostly.
No shot.
Alright, hello,
Okay.
YouTube playback. This is day 3. Yeah, but it's the 3rd time that we've met. Day 3 of the 525 Java programming training.
I'll go over real
called
quick for
Geek
how
Week.
to pull everything down for us yesterday.
We hope you learn a lot.
Yep. So for everyone who wasn't here yesterday,
That's me.
we'll real quick get you up to speed, get you the code that we had yesterday. So what you can do is, if you go to GitHub, which you should all be in our GitHub, if you
Raise
are.
your hand if you're not in our GitHub. 2 people.
Okay. 2 people. Yep.
I don't have my
Yo-
computer right now.
Oh, you don't. You just need to download the zip file. Okay. Well, we'll get you into our GitHub. Do you want to do that now or do you want to do it later? Probably just later. Okay. So basically, you'll go to this repo. It's just, if you type that into the top, the search bar. Well, actually, I haven't pulled up on your computer already. I'm not here already. But for Carlos, if you type this in, or do you have Slack on your computer? You don't, I don't think.
Just go to the search bar and type.
Yeah, just type it in. Just type this in to your search bar. Just GitHub.com/Geek Week 2024. And- Yep.
Uppercase 4?
Yep, totally.
4 has cases now?
Yes.
I mean, if you want it to.
Uppercase 4.
Yep.
It's bold 4. It's bolded.
It's actually just a dollar sign. Hello, Wyatt.
First thing, let's go to GitHub here.
Why is
Yep.
here?
Okay.
In the search bar at the top,
Oh, man.
just search for.
I just came from there. Unfortunately, my mom didn't let me get ice cream because we ran out of time.
Aww.
You can bring ice cream here.
Yeah.
Just don't spill it on a
Go ahead
robot.
and refresh.
Or preferably the
Or
carpet.
the carpet. I mean, if you spill it on the carpet, you're
Alright,
gonna
go press the back button, I guess.
Okay.
Sometimes GitHub decides.
I'm trying to make content.
So Violet, because I actually have the repo itself installed on the computer that you're on. If you go to VS Code, so go to VS Code. It's on the bottom. Yeah, the symbol should look like this, with like a little white box around it on the taskbar. You found it?
I have no idea.
Eden, can you help Violet get to VS Code?
Am I like? So I'm looking up VS Code on my computer and I do not have it. I have 2024 different.
That should be it. Yes, that is it.
Different icon.
Yes, that's fine.
Just making sure.
So when you open it up, I believe it's the same icon. It just has a different weird icon. Yeah. So
It has no icon.
for Violet only, because my computer already has VS. It's weird. So go to File, and then there'll be Open Recent. It's at the very top. It should be at the very top. File, Open Recent, and then it'll be one that's Geek Week 2024. Do you see that?
Okay, so what you'll need to do then is go back to your web browser, and then we're going to do a Google search here. So you can search for FRC control system. We'll click on that first thing.
Well, I was
You have it?
Yeah.
Yes.
Okay, we usually meet on Friday, so the group was like small. Oh my god, boo, loser.
Hey, Smart Dog. Reese, were you here yesterday?
No.
Did someone help get Reese going as well? You got it? Cool. There was just a lot of volume, so I couldn't tell what was happening.
Yeah.
I can all make Keegan later.
What?
We can all make fun of Keegan later.
Why are you making fun of Keegan now?
How would I do that?
So what do you need?
I'm just trying to sign
I
up.
haven't had time on time to watch it on Friday.
That's
I'm
totally
just on the
fine.
3-day.
That's totally fine. So some of the terms that we
Why?
read today might be a bit familiar.
That's alright. I'm planning to watch this tomorrow. I can't hit 3-day. We'll do it on
Bad writing, so.
Fair, understandable. Those are the files that we made yesterday. And that we- oh wait, here's the other thing actually.
Wow.
Also, can someone help me just start college? Keegan's home.
So you had it downloaded.
I downloaded it
So we
and.
started the good VS Code.
Oh my god.
Sometimes.
I'm not a human.
I figured that that's what you do, but.
When I did it yesterday, I accidentally recorded all
Oh,
the
no.
notes.
That hurts. Oh, that's.
That's
I don't know.
because.
Doctor like it that. It hurts when you sneeze.
Oh,
You can see.
SRC made.
Let me guess. Sam?
So you're not gonna join the balance team?
You are. So those, that group.
Oh, it's not?
So go back to VS Code.
So,
I can make
so
one.
basically, I just do the low
I
mini
don't,
right
I
now.
don't.
Is that what you're saying?
The library?
What, at what
Oh,
point?
Yeah.
Well, playing Valorant is wrong.
Yeah.
That doesn't feel like the red light is. Yeah.
Yeah, so then if you go under SRC, or Java, I don't know what they are.
I prefer Windows. The only thing I like MacBook for
Get
is
dirty.
easy access to
You're
keyboard.
gonna get-
I don't.
If you were a coder, you
Why are we
Except
getting
if I
dirty?
get MacBook on Windows.
Except if I can take 5 years to
I didn't know you told me.
So, where's your
No, I'll figure it out.
Are you on the
Are you in
ballot?
CSA?
No, he's not. He's a
I am recognizing that what is happening.
What are you doing Friday?
I'm
Let's go.
I'm sort of
Oh.
getting. That was telling me what's going on.
To be fair.
Well, actually, we already have another guy. We actually have two teams this week.
Okay.
I think so.
Okay, so I don't.
I have good news.
Okay, we're not.
What's going
Our
on.
team won 3-1. I have no clue how. We're all wrong too. I have no clue how.
So-
It was out of there.
Do you download the installer or download
That's amazing.
Hey, what's up?
it? So try checking if you have VS Code.
College team.
I can help.
That's the best. Oh my god.
Alright, to be honest, that's the.
So check the reach out. No. So then everybody just needs to go back to where you were.
I really don't know.
So, I'm thinking either late afternoon
It's
or
normal,
start
right?
school.
No, it's legal.
Right?
It's legal, James.
Why do you just, why is it in this?
That makes it sound like.
Oh, hey, looky
Makes
there.
it sound like it's illegal. If you said this is
So-
illegal, that sounds more
Is it
legal.
Leo?
Yeah.
You can just call it Leo.
He doesn't know what that is.
Should we start? in the-
We should start because I've been recording for 12 minutes, so I'm gonna have to cut this
I
part
don't know, you look.
of
the
the
other
video.
Yeah, do you have the code from yesterday?
Yeah, I have
You
it.
got it?
I
Okay.
have 6 errors, but I have it.
Hold on.
It's the get
Oh.
errors. I don't got get.
The get errors.
What do you mean, what? Why would I have get knowledge?
I did because
You should get.
Look at how quickly that moved on.
Windows is good. It's just so they're not playing shit 3D. I think they're still good enough
Are
that
you proud of me knowing how to unlock
but
comments?
so they're getting.
Okay, so you downloaded Linux.
I think Linux will probably eventually.
Why is this broken? You got it.
Why would I know that? Why would I know that?
You would know that if Cedric actually told you that.
Yeah, no, Cedric doesn't nothing.
Cedric needs to lock you and I changed my mind.
I hate it here.
Cedric, go here, dude.
So when you build your code,
They branch
yeah,
in it.
Alright, download that one.
It should work.
Wait,
It won't like die.
why did you have a
No, do it now.
I hate it. Okay, how do I get rid of all this?
Once you guys go
Okay.
And then they'll say build.
You have a lot of friends. You used to not have friends. Now you have a lot of friends.
Yeah. Oh my god.
That's why this.
Actually, you spent 5
Do not high five.
Too late. You're too late.
I heard that you're not high five. It was a great experience.
Hey, both of you heard that.
It's up to my discretion.
Should we get started, guys?
Yes.
I think we should get started.
The other
Guys, I think we can get started. Okay. So as you knew from yesterday, real quick, does anyone who was here yesterday remember what this all means?
All right, Smart Dogs, listen up.
Does anyone here remember what Colin wrote all this out? What did he mean by all this?
Reasons for the power for the weak.
We should raise our hands and explain what
Keegan.
it means.
Doesn't it like represent the power that's gonna go to either side?
Yes. Do you remember the reasoning behind all this?
Yeah, so with the diagram, it shows that like when we want to go forward, it's left is going forward with positive D, and then so is right. So both have positive drive, and then when we're trying to rotate, the left gets added rotate, while the right gets subtracted the rotate value.
Exactly. So we did all the math, but we haven't put it actually into our code yet. So that's what we're gonna start with by doing. So, does anyone have any idea how we start this?
So we actually went a little bit farther in our
Oh, yeah.
description yesterday.
Well,
So we talked about the L equals D plus R. That's left equals drive plus rotate, and right equals drive minus rotate. And the idea here is drive and rotate. Those are the inputs that we're getting from our driver's joystick. And left and right are supposed to be the voltages or the powers that we're supplying to the left and the right side. And yesterday we also talked about how when we try to, when we get our drive and our rotate inputs from our joysticks, those are given in terms of a percentage. That percentage is represented in the range of -1, meaning negative 100% power, or 100% backwards, to +1, or 100% power in the positive direction. So both our drive and our rotate are given in that range. And so when we add them together, we might find ourselves in a situation where we're telling the left or the right side that they need to drive at a power that is greater than 100%. And so we were talking the little 200 divided by 200 and 100 divided by 200. That's us starting the process of figuring out, okay, when I do have a side that needs to go faster than 100%, how do I handle that? So in plain English, the way that we handle that is if one of our sides needs to go faster than 100%, we find whichever one of those is bigger, and then we divide both sides by that maximum value. What that ends up doing is it keeps the biggest one capped at 100% because any number divided by itself is 1. And then the smaller number, because we're dividing that by the maximum number, we keep the same ratio between the two sides. And that is going to give us the motion that most closely represents what our joystick is actually doing. Does that make sense? Does anyone have any questions on that? All right, that was the plain English. Now we got to turn this into code.
Yay.
All right. Cedric, take it away. Or do you want me to take it away?
I mean, I
take it
can
away.
take it away.
All right. I'll talk, you
Okay.
type.
Someone take
No, I mean, I know how to do it.
Well, I know you know how to do it.
Yeah. Okay.
Okay, so what part did we start with? We started by saying we know how to calculate our left side and our right side. Those are the two formulas on the top over there. So let's start by writing the code to find those two numbers. So, yeah, you can write.
Okay. Or do you want me to talk, or do you just you don't want to talk?
Go ahead and type the code. I'll talk.
Yes. Why is
I
it?
don't
Why is
know
it?
what the name should be.
Oh, that's weird.
But I can look.
Oh, gosh, it's crazy.
I got the data type right though, so.
Yeah.
No need.
I don't know how to spell it. You're doing too much better.
Is he?
I mean, yeah, variable name. We have what a variable name is.
Yep, so what Cedric has written up here is the top two formulas that we have over on the board over there. So if our motors didn't care about, stopping at 100%, like the quitters they are, we could give these left side and right side numbers directly to the motors, and the robot would drive how we want it to. But they don't. They do stop at 100%, and so we need to account for that. So does anyone remember what the next step we need to figure out is? Josh?
You have to figure out which one of the numbers is gonna be bigger.
Yes. How do we figure out which number is bigger?
Equality.
We can use an if statement.
I'm like,
I'm sorry.
Max?
We can use.
WPI has something that was like max, and we can find it.
It's not even
Math.
part of the WPI though. That's just part of
Mod.
Java itself.
Yes. Oh, yeah.
Not right.
Yes.
We do not need
Math.
modular or arithmetic right now.
So we can
Yep.
just-
So
Write it in the-
greater than and less than, we would use that in conjunction with the if statement.
But this is faster.
So
Okay.
we'll do max.
Do we only need to calculate it if one of these is over 100?
We only need to apply it if one of these is over 100. We can calculate it regardless.
Okay.
Whenever I implement this, I like to calculate it every time just because it makes it a little bit easier to compare to see if I need to apply it.
Fair enough.
So
Why is it not IntelliSense?
it is math. Math dot, and then we're
Does
looking.
anyone have an idea what this could possibly be called? It's just
Yes.
Max.
make sure it's a double.
Funny story. Method overloading, but we're not going to get into that.
Oh, you got rotate in there.
That's weird.
it's like-
You're right.
Why do you
Because-
have rotated Michael?
Because GitHub Copilot decided that those were what we needed to put in there.
It's being really
AI.
weird right now.
This is AI, everyone.
It's going to steal your job.
I really doubt it's gonna steal all of our jobs.
True.
Okay. So we found our max value, and now we need to check to see if that's above 100%, right? How do we check to see if it's above 100%? Yep, we need an if statement. So if, and what's our condition? Max is greater than or equal to.
Well, it doesn't even need to be equal to.
We can just do greater than, because dividing anything by 1 is not doing anything at all. And how do we represent 100% here? Number 1. Yep, I see Keegan.
Not
How do I
10.
do greater than or equal to sign?
Let's do 1.0, just so we know that we're dealing with doubles. It's not strictly speaking necessary, but
1.00.
felt weird not having the 0.0 there.
I'm gonna put my curly brace on the other line.
And then what do we do if our max is greater than 1?
Then we need to do that calculation.
Indeed.
The bottom numbers.
Any idea how we do that calculation?
We do some math and we divide by the max and the other one by the max. But we need to know which one is the max. No.
Do we?
No, we don't. We just do both.
So just do both. So both our left volts and our right volts, we need to.
CSA kids, you could use a compound assignment operator here.
How about mod?
No.
We don't need mod.
No more.
Mod will make things worse for you.
Remember that this is getting recorded and uploaded for other teams to use. So if we can keep our funny but mildly confusing comments to a minimum, it would be appreciated, I'm sure. I'm giggling on the inside.
Taco Cat spelled backwards is somewhere.
Cedric, your S key just does not like to press it.
That's weird. I don't have that problem. I don't have that problem.
Okay.
Not on that computer.
It's true.
That's weird.
It's harder to push down than the other key.
That's like the treat in every
There's no video games on that computer.
All right. So we've calculated our max. We've checked to see if that's greater than 100%, and if it is, we scale down our left side and our right side to be less than that 100%, but still maintaining the ratios between the two. Now that we have those scaled values, what do we think we do with them next? We've got a voltage that is inside the range of negative 100% to positive 100%.
Two of them.
We apply them directly
Yes,
to the motor.
exactly. Any idea how to apply them?
No,
Me neither.
This has to do with what we did yesterday.
I was not serious.
For the people who were here yesterday. Zach, do you have a computer, by the way? Okay. Is that a Chromebook or is that?
That's Chromebook.
Do you know how to get on live share?
No.
Eden, can you help Zach get on live share? Colin, can you maybe help?
We will need someone to host.
I can host.
That works. Okay. Do you have live share installed?
I don't.
Yeah.
Okay. So what you need to do to install live share, Kirkpatrick, is you go to extensions on the side,
Oh gosh, which side?
the left side. It's the fifth thing I can count. Just look up live share. And then you just install the first one that pops up. After you have that, you should have another tab down here now. You click share, read/write. It'll instantly copy to your clipboard a link that you can just Slack to Zach.
So for all
No.
Did you lose a second GitHub account?
No. I still have it. It's okay.
So I just kind of like two of them plugged in on my desk, and I just like switched.
So your live share session started.
I think I'm
So
letting you charge when.
Hey, Zach, I'm gonna Slack you a link.
If you want him.
No, I don't.
Dang. Okay, that's fine.
all right.
Well, now you have live share for whenever you need it. So
Okay.
going back.
Thank you.
So someone who was here yesterday, do we remember what we spent the vast majority of the day working on? What is it, Ethan? What did we start working on? Yeah, let's go take a look at Drive.io real quick. So, does anyone remember what Drive.io actually does for us? Josh?
Gathers data from the different motors and gyros.
That's one thing. It does one other thing.
Also sends out the data.
Oh, sorry, go ahead.
Also sends outputs to the motor so it can control the voltage.
Exactly. So all these methods down here, that's how we actually control our hardware. And if we go back into our drive subsystem, we'll notice, actually, Cedric, go ahead and scroll up a little bit. One of the variables that we have in this class is a drive.io variable. And because that is a member variable in the class, that means we can use it anywhere inside our class. What that means is we can go down to the bottom of our drive method and we can say, hey, IO,
I want you to set my left power and set my right power. So we need to tell an object to do something. How do we do that?
Well, we have
we
it.
create
Say
it.
method.
Say it louder, Zach.
Use a method.
Use
Yes.
a method.
And how do you call a method?
Using the dot operator.
Perfect.
Yes.
The name
Amazing.
of the object you would like to call the method on.
Perfect.
And the method name and parentheses and the semicolon and any arguments as is necessary.
Perfect. You got everything.
Aren't you so happy that CSA exists?
I am. This is going so much faster than it has in years past.
So do you remember what our object name is?
No, it wasn't here.
_IO?
Yep.
Exactly.
Yeah.
And then, as Zach said, the dot operator. And then
Power left?
Yep.
it is. Oh my gosh, no
Mm,
intelligence is really
you
sad.
might need to clean your Java language
Yeah,
server workspace.
We'll do after these 2 lines. And then does anyone have any idea what's missing from this line?
Arguments.
left volts,
Yes, exactly.
which is an argument.
Yes.
We'll do the same thing for the right.
Oh my gosh, what the? having the screen be at a really weird angle is not great.
All right. So what Cedric's doing right now, not everyone needs to do, but sometimes in VS Code, Java just
Breaks.
stops working. And so sometimes you need to tell VS Code to tell Java to restart.
So it's clean?
Yeah,
Okay.
it's more just IntelliSense stuff and like formatting
Okay.
than actual functionality. But
It gets tired and needs to take a nap.
yeah,
Yeah.
basically, it needs to reset.
What you do?
I basically just clean Java's language server workspace, which just resets
It
Java.
looks like up in that top search bar, start to type the word clean.
Yep. So if you need to ever do that, it's the top command right there. Clean Java's language server workspace. It will not necessarily be your top command because I just used it. It's my top command, but just type in clean, it'll probably pop up. Anyways,
Okay.
anything else in Drive?
We'll figure that out.
Yeah.
Not needed right now.
So now that we have our drive function written out, I want to walk through a couple of examples. So let's do our first example from yesterday where we're driving all the way forward and we're rotating all the way to the right. So in this case, drive is going to be 1 and rotate is also going to be 1. So left volts, what do we think the value of left volts is going to be? The drive and rotate are both 1. 2. Right volts, what do we think that one's going to be? 0. Yep, because 1 minus 1 is 0. So then we're going to say max is equal to the maximum of left volts and right volts. 2. Perfect. If max is greater than 1, is max greater than 1?
Yes.
Awesome. So we come in here. So we say left volts is equal to itself divided by maximum. So what do we think?
2 divided by 2 would be 1 and 1 divided by 2 would be 0.5.
Exactly right. So that 1 is left volts and the 0.5 is right volts. And then those are the 2 powers that we
Wait,
need
isn't
to.
rifles 0?
Yes.
Okay.
You're right.
Okay.
So Drive by 2.
Yep. Sorry. Yes. 1.
0 divided by 1 is just 0.
1 minus
divided
1.
by 0 is bad.
It's breaking.
1 minus.
divided by 0 is something went wrong.
Okay. So now, one thing I do want to bring up. So we said that left volts in this case is 1 and right volts is 0.
Mhm.
That 1 and 0 represents our percentage, right? 100% power and 0% power, right?
Mhm.
What unit was our power left and power right expecting? Volts. And we're giving it 1 and 0. So if I
1
take
volt's
a
not
12
very
volt
much.
DC motor and I apply 1 volt to it,
Ooh,
That's not 100%.
100% at all. We need to like multiply by 12.
Yep.
Yeah,
There are technically more correct ways to do it, like by monitoring the amount of voltage that is actually available to the motor controller. That's overkill. We're just going to multiply by 12.
Why do the complicated stuff when the simple stuff works?
Exactly.
Anyways, all my things closed.
Okay.
So.
All right, so we fixed that issue. Let's go through one more example. Let's say I'm going exactly the opposite direction. Let's say I'm going all the way backwards and all the way to the left. That means that my drive is -1 and my rotate is also -1. So left volts, drive plus rotate, -1 plus -1,
-2.
-2. Right volts, -1 minus -1, 0.
Oh no,
What's
That's a bad.
What's our maximum between these two?
0.
It's 0, which means we're not going to go inside this if statement, which means we're going to tell our left volts or we're going to apply
Negative
Negative
24.
negative 24 volts to the motor. The motors can only do 12. So we've got an issue in our code here.
Yes. And also 0 volts to the other.
But that's
Yeah,
That's fine.
because
That's
we
fine.
put all
Zero
sides
volts is
to
fine.
zero
That's in the range of
drive.
-12 to
We didn't
12.
specify for both drives.
What's that?
We specified that only that to left and right for regular drive. We switched stomach to left drive and to the opposite to right drive.
So the issue isn't with left versus right specifically. The issue is that check that we're checking for are we greater than 100% power? That only checks to see if we're above 100%. It doesn't check to see if we're below -100%.
Yeah, so we need to make a second half of that.
Do you guys remember the thing in math?
That's a very
Like
Ooh.
this?
absolute
Not a square.
absolute.
It does
The straight bracket.
Yes. What's that called?
I don't know.
Absolute. Or the
That.
absolute. That doesn't look good.
Mod.
No. Absolute value is a thing. Does anyone remember what absolute value does? Yes, Gabe.
It shows.
It makes it non-negative.
Okay, fine. It shows the distance from 0.
Yes.
So
And the distance from 0 can be 0. And 0 is not positive. It is 0. It's neither positive nor negative.
fix it up.
Zero.
That's no negative count.
So, do you guys think that there is a way to apply that function here?
Probably.
Probably. I mean, we have whatever its object, so
Just
there's
put
probably a way to
Library.
use absolute value in the math object.
Library.
Yep.
Then wouldn't that run into the problem of, if we're, no wait, never mind.
So yep. Somewhere I'll give you a hint here. Somewhere on line 20, we need to use this absolute value function. Where do we think we need to use it? Keegan?
Inside the parentheses, what do we do? Like math.abs, parentheses left volts, and then math.abs right volts?
That is a way to do it. Does anyone have any other ideas? Zach?
Are we able to put both of them in the same absolute value?
So the absolute value function provided by that math class only works on one number.
Okay, never mind.
Why can't I put the math.absolute value outside my math.max?
Because it's not finding if it's left or right, just both, and it only does one. So just do left, just the first thing.
Not quite.
So max does return a number, so it would get the absolute value of the max. But
It
think
would
back
get-
to our -2 and 0.
0
Example.
is bigger than -2, so it wouldn't return the -2 regardless.
Right.
Yes.
It would just return 0 and we would still have the same problem.
Exactly. Yep. So Keegan's suggestion here was right. We need to take the absolute value of both of these. Okay. So then, because we're taking the maximum of two numbers that are greater than or equal to 0, it's okay to check to see if they are, if that maximum is greater than 1, right?
Yes.
I see hands raised. Do we have questions?
Yes.
I have a comment, so I'm gonna
Okay.
let the question happen first.
So why wouldn't we just check if max was less than -1 as well?
We could do that. We totally, completely could do that.
If max is less than -1,
Yeah, if max is less than -1.
but
only
the
issue-
zero, the -2 0 case
We
still
need it.
would not work.
Well, So we could compare to see if max is less than -1, because in that case, that would, we would still need to divide.
Oh, gotcha.
Now, think about it this way here. If I'm taking the maximum of two numbers that are greater than or equal to 0, will max ever be less than -1?
No.
No. So we don't have to check that.
We could. Oh, we don't.
Okay.
Oh, do you still have a comment?
Yeah, because I just want to point out that what values can max not be now? Can't be negative, which is good because you might want your left volts to be negative, right? And if you divide a negative by a negative,
So you better
would your left volts be negative anymore?
No.
No. Oh, I love math.
That's why it's super nice to have max be positive here, because when we divide here, even if left volts is negative, say it was -2, max is going to be +2. So we get that division, we're back down to 100%, but the sign is retained.
Amazing.
Right?
Thanks for
it's something that
inviting
you
the
might
math
not
teacher.
have thought about, but it still works and it's beautiful.
Yes.
Oh, math.
I know. It is beautiful.
Okay.
Okay.
Thanks for inviting the math teacher.
Does anyone have any questions on what we've written here so far?
No.
Does it make sense? All right. What's next?
We should either
I think, have we finished our periodic yet?
Yes, say
It didn't do anything.
Do we need? I don't think we need to log where it is.
What's that?
Because like normally our periodic has like a place where we log in and other functions.
Yep.
It should be fine for now.
Things that you enjoy.
Oh, no, you're right. We totally need to tell Advantage Scope or Advantage Scope logger.
Yeah.
shut down his computer.
Well, I can't program it the rest of the time.
Okay. Our two student leader programmers have reminded me here that we didn't actually finish our periodic method yesterday.
Oh.
Oops. Who remembers what the periodic method does? Josh?
It like checks our sensors every 20 seconds.
That's what we told it to do. Even more general than that, the periodic method will do whatever we tell it to when.
Periodically.
How periodically?
Every
Every
20
milliseconds?
milliseconds.
Every 20 milliseconds. That's just a default in FRC programming.
Can we change that?
Yes.
Do we
Never had a
every
reason.
1 nanosecond?
Yeah, we've never had a reason to change it.
It might be fun.
So if you change the period to be faster, your code is more responsive, but your RoboRio has to process more.
Yeah.
And if it can't process it,
It's
also
like staple on a bunch of Raspberry Pis, give it more processing power.
Raspberry Pi is not what you go to for more processing.
So we need to update our periodic function?
Yes.
Awesome.
So right now in the periodic function, we are telling our IO object to update our inputs.
Okay.
The next thing that we need to do is we need to tell AdvantageKit to actually record those inputs. Update
So if you
inputs.
want to go back to our IO class, all our update inputs does is it updates our attributes. It never actually logs them. Yes, we do. So, do you want me to just take this?
Was
Yeah, go for
update,
it.
was update input supposed to be something?
Yes.
Not in the interface.
Okay.
Oh yeah, because it's implemented.
Gotcha. Wrong file.
So, for actually processing our inputs, which is the function, what you need to do is we need to go to our logger, which don't worry, it's inherently built in, I believe.
Make sure you get the right
But make sure you get the right logger. It's the third one, the one that says loads and robotics dot junction tab dot. Gosh, I just forgot. Process inputs,
process.
and then you have a string, which is the name of where you want to log it to, and what you're logging. So, as it's so kindly filled out so far, underscore inputs is what we want to log. Does anyone have any ideas for what we want to log this under?
Drive commands.
How about just
Stop
drive?
halfway there.
How about just drive? Yeah.
Drive.
And it's a string.
Yes, it's just a string.
Wow.
line isn't a number.
You can capitalize it, you don't have to. All this string is used for is when we're actually looking at our log. This is the string that is, the label that's applied to our inputs to say, hey, these are our drive inputs, so.
I'm just trying to tweak the code on Cedric's computer as close to Cedric's coding style as it can be.
It's fine. It's fine if you mess it up. It's just fine if you do something different. I don't know.
And are we taking inputs and processing them?
That's basically what it's doing. Yeah, it's automatically processing the inputs that we have updated through our previous line.
Awesome.
So previous
What
line,
data type is inputs?
a drive IO inputs auto logged.
Okay, cool.
So it's just the inputs because in drive IO we created a class within our interface
Uh-huh.
that's drive IO inputs.
Okay. Yeah, so there's
So,
just a lot of data
yeah.
chilling out there.
Yep, and because it's auto logged with the. Oh my gosh, you can put it in there.
That annotation is
Annotation.
special Java magic that essentially, the team that made Advantage Scope, they have said, when you compile your code and you have a class that has this @autolog annotation on it, we're going to generate a brand new class that is, it has the same name as your class. Autolog.
All logged.
Autologged is at the end of the
you
class
look.
name. And then it's got all of the variables that you put in there, and then a whole bunch of extra stuff that we don't have to care about.
Thank you.
So I believe that should be it for our drive subsystem.
Yeah.
Woo! Save and
So, if you guys remember our 3 classes that we have done, we have the drive subsystem logic class done, we have the IO or input output class done, and we have the hardware class done. Does anyone remember what is the last class we're missing?
Yep.
Yes,
I heard it. He's right.
exactly. So we are going to create our subsystem class. So to create a new class, we right click on subsystems. You'll go down to create a new class / command, create an empty class, and this will be called drive sim.
Drive IO sim.
Drive IO sim. Okay, drive IO sim, and then you'll push enter.
Java.
You don't have to write .java because it's already going to automatically do that. So you should have something like this when it's done. And you can delete the comments if you don't want them.
Or you can leave them there if you do.
Yeah, up to you. So I'll give you guys a second to get to this point.
I love keeping the copyright information.
My team at work got in a lot of trouble at one point because we were deleting comments that had copyright information. And when I say in a lot of trouble, I mean, my boss said,
Slap on the wrist.
Yeah.
Yeah.
Okay.
there was no legal trouble.
My APCSP friends know all about copyright.
Okay. So, is everyone here? Give me a thumbs up if you're done. I'm looking for thumbs up for everyone. Okay. Well, give us a couple more seconds.
Help out your friends.
Yeah, if you guys help out your neighbors, check on them, make sure they're doing good. They need help.
Awesome. I have no friend over here.
I'll be your friend.
Did you get there?
I did. I did.
Did you get a degree in mathematics?
No,
No, I don't.
not a real degree.
Math
Don't think that's something.
Mathematics.
Mathematics.
What about mathematics?
I think I could
Mathematics.
Yes.
I knew it
I did
all
make
along.
some-
Yeah.
I've gotta be math
But I know
teaching.
why.
Right.
Oh.
Right.
You're so
And I got a degree in applied computer science.
Because you're a teacher.
Teach people what variables are for a living.
And what mutator methods are.
Yeah.
And she submitted accessor method.
And accessor
She
methods.
admitted math.
From class A
I was
methods.
too busy obsessing over the name.
So you are not an APCSP kiddo, so you don't understand the joy that Silas gonna feel tomorrow when we get to make, not tomorrow, on Monday, when we get to make a flippy do, but this time for APCSA.
FRC.robot.
I still got my other ones.
Yes.
Mine.
It's gonna have a class, and then it's gonna like flip over all the names of the stuff, so like class header, it's very cool, so everyone's
Oh,
like,
yay.
thanks. It's arts and crafts day.
Oh.
You're gonna have to cut things and write all that.
I won't be there.
Oh, yeah. Well, if you ask nicely, you can have the teacher.
No.
Because I'll have to make 2 more.
I am not gonna make a 50 because he's not here Monday.
Oh.
Yeah.
You can make 2 and give 1 to Wyatt.
Okay, I'll be back.
You start to leave it. Bills,
The
whatever.
one that you read my handwriting, I think you can, so I copied my French notes before.
Because mine doesn't work like that.
No.
Okay. How's it going?
Carlos, you good?
No.
Are you like good mentally? You look a little out of it.
Oh, I'm tired right now. I just went to the gym and then I came right here.
Gotcha.
2 minutes.
Gotcha.
You can tell because it's a little swole.
Aw.
Yeah, go ahead.
Yeah,
I'm gonna take a picture of this.
Okay, guys.
Patrick, he's taking.
Focus, Fox. Focus, Fox. Focus, Fox. We're moving on. So people are gonna keep on working over there. In the meantime, we're gonna look at an example. If I can figure out how to work this. Oh yeah. Okay, I figured it out, guys. One sec, guys. Why is this not working? Okay. Can you guys see this? Can you guys see GitHub?
Yes.
Perfect. Okay. So we're going to look at an example of a sim class just so it's easier for you guys to see it visually and see how that works. So we're going to go to our last year's code for OD, and we'll look at this really quick. So let's pick a subsystem. Let's go make it kind of easier. Let's go to Gyro. That's a pretty easy subsystem. So first of all, let's look in the Gyro IO class. What are the inputs we have right here? Yeah, these are just our variables. They're just like the degrees.
Can you zoom in a little bit?
Yeah. So I can zoom in. Yeah, it's like
yaw position, roll position.
So these are kind of the variables that we have in here. Actually, let's go use the I want to do the intake. That has some methods in it. Okay, I changed my mind. Here we go. We have the intake of OD. So we have motors and current, and we have update inputs, and we're setting the volts. Kind of similar to what we have for our current code that we just wrote. So this is our IO class. Now we're going to go over to the sim. Here we go. So we're going to go over to the sim class and take a look at this. So in sim, first things first, we need to create a virtual. So this is for last year's code. We have a motor for the sim class, and we needed to create a virtual motor. So we created that here. Then we created a variable for voltage, and similar to the IO class, we had an update inputs with our inputs and calling that, and then updating our motor sim. And then we also had our set volts, which was in our IO class, if you guys just saw. So we're using that, and also you can see, what does this implement? Just shout it out. Yeah. Yes. So our simulation class uses our interface. So we're gonna go and we're gonna code that now. So we're gonna go back to VS Code, back to our Drive IO sim, and first things first, what do we need to do? Based on what we just saw, just like what do we need to create first?
The class or import or what was the word?
Cool. What did you just say? Yes, we need to create the virtual motors first. We need to create some objects for those. Everything good?
Sorry, I want to check something super quick here. So just so we're all on the same page with what I'm doing, all the code that most of you have been writing, most of you aren't going to be able to successfully actually build your code. And the reason for that is because when we go to build our code, under the hood, Visual Studio Code is using this program called Gradle to actually take the text file that you've written and turn that into machine code that we would then put on the robot. The issue is that Gradle executable can't run because it's not properly installed because we accidentally didn't commit everything that we needed to. So I will send a link out to everyone here. Let's see. You saying what I'm? No, you're still on the
Just bring it up.
It's extended. Oh, hold on. Let's do this.
If you can show the link, for people who are following along on YouTube, that would be great.
It's the same thing. Share it over here.
There we go. Okay. So there's a couple of files in this Gradle folder here, specifically this Gradle wrapper.jar and Gradle wrapper.properties. We want both of those files. So what I'm going to do here is I'm going to click on this link here. I'm going to send this in Slack for everyone. And then you'll want to download these two files and then put them into your project. I'll show this whole process here. Let's see. Are we on Slack right now on this computer? I don't think we are. Let me log in real quick. All right. I'm going to put this in the programming channel.
We'll put in the general because I'm not sure if everyone's inside the programming channel.
All right. We'll do general. Oh, general. Where are you, general? General. Okay, I just sent that link, so everyone should be able to get to this page right here. And what we're gonna do, what's that? Oh, I was trying to see, is there a way we can just download these files? Yeah. Unfortunately, we got to download them one at a time. So if you click on one of the files, so in my case here, I've clicked on Gradle wrapper.jar. There's this download raw file button. Click on that. Keep.
It will not harm your device. I promise.
And then, yep, we'll want Gradle wrapper.properties as well. So once those are both downloaded, we can go back into VS Code. And then we'll need to make a new folder. We'll call that folder Gradle. Just at the top level of the project. So I like to click down in the blank space down here with everything minimized. Click on the new folder button. And we'll get a Gradle folder. Then click on Gradle. Then you're one of the special few who was already able to build software. And you probably don't need to keep following along. And then inside the Gradle folder, we're going to want to create another folder called Wrapper. And then we'll go take those two files we just downloaded and drop them in. Yep. If you click on it, it should say, "Yep, you can't open a Java archive is a special kind of file. It doesn't make sense to open it." Okay. Yes. So once you put those in there, you can try building, and we can. I skipped over it. I can show everyone how to build in just a sec.
This jar file.
Mm.
It doesn't like me. It's
Is it task on build?
No, there should be a WPI lib build robot code.
Rest build robot code.
I make great awards now. You basically.
Build successful in 42 seconds.
Sweet.
Yay! All my data structures kids can figure out the time complexity and see what constant is. 'Cause that's what we were doing. We've been doing a lot of math. They've been hating it.
And
So you press.
in
I
my
just need to host my
Build failed.
build failed.
27
Wait,
seconds.
did you get it? Yeah, I get it.
Alright.
Yeah.
Phil, did you get it?
Oh, wait, so you see that? No, this is down in the so it's a second.
Oh, I forgot to remember that shit.
Alright, I got it. I got great. I just.
File there.
Did you miss a semicolon?
So download the files. And then I believe. Nothing like that. Probably just drag Colin,
yeah.
is there a better way than just dragging the folders or the files into the folders?
If you know where the project is on your computer, you can copy and paste them into the folder outside of VS Code.
That's what I was talking about.
Oh, drag them into the
Oh, Control X to cut, and then Control V to paste.
Okay, so yeah, just press the list.
Okay.
Files. Yep, and then downloads. So fails, 36 seconds.
Build failed. My build was successful. I've been paying attention. I'm a good student. I'm a good student.
I failed. I never failed. I never failed.
I'll fix it for you.
If you want to keep why is ClickChamp 228 gigabytes?
And then
It will search.
I deleted it.
I don't know. My wife.
Good job.
So we're
Yes.
I'm going to delete that.
How? That's fine. It's because it's in a weird format. You can open it if you want to. It's just in like binary or something.
Okay, guys. Is everyone raise your hand if you're okay to listen at least? Okay. So just try to listen. If you're having troubles, we'll help you out. But so just to recap, if we go back to our class example. Whoops. Where are you? Okay, we're gonna go to Crescendo code. Okay, we have this intake IO sim, and it implements intake IO, and it also creates a private final DC sim motor, and using that stuff. So we're gonna do something really, really similar. Okay, so we're gonna go back to VS Code, and then what do we think the first thing we need to do?
Implement.
Yes, so we have to make sure it implements our IO class, IO interface. I mean, that's how you spell implements. There we go. Okay. Okay, and does someone want to raise their hand and tell me what this does when we say implements? Keegan.
It inherits all the things that drive IO interface.
Exactly. So next we're gonna
How is that different than extends?
So extends is specifically for the class, not classes,
Yes.
subclasses, yeah. For subclasses, but implements is just something you do only for interfaces.
Oh, it's an interface thing. Got it.
Okay.
Thank you.
Yeah, of course. So first things first, what accessor methods is going to be if we want to create something like a motor
Your accessor?
or your access modifier, I mean.
For a motor?
Mhm.
Private?
Yes. So,
Accessor.
and then because it's unchanging, we're going to write final. And then, do you know what the class is?
DC motor?
Is it DC motor sim?
I think it's just DC motor.
Not sim.
Even in the sim file?
I think in our example, we use
I
the.
think it's DC motor sim. I know more than Colin, obviously.
All right, let me see
Here,
what we did
wait.
last year.
Colin, I have it up.
You have it up? What did we do? Oh, we did do DC motors. Oh, that's right, because you can't make a DC motor just by doing new DC. Oh, maybe we can. I don't remember. We're gonna do that.
Okay.
We're
So-
gonna do the thing that you said that we should do.
So we're going to go back to our code and we're going to write DC motor sim. It should pop up. And now we're going to write our variable name. So what do we want to call this? Motor sim. And are we going to have multiple?
How many motors does our robot have?
4.
So how many motors do we think we want to simulate?
8. Because I disagree with that rule.
We're gonna go with 4.
Okay, so what are we going to call this one then?
No.
What do we name our motors for, guys?
FL motor. FR motor.
Mhm.
What do you think we should name our simulated motor?
So
FL sim motor.
Same thing.
FR sim motor. Or
FR motor sim.
Oh, hey.
Okay, so we'll start with this one, then we'll go new. Because we're creating an object, we're going to go this. And this has some arguments that we have to fill in. So if you hover over this, it says the parameters it needs is a gearbox. So the type of a number of motors in the DC gearbox, the gearing, and the JQ meter squared. So we're not really going to go over what all of this means because I don't even know what all of it means. So Colin's going to tell us what we need to put in here.
Colin, do you know what this means?
I know what 2 of those 3 things are. So the first argument here to the constructor for DC motor sim is it needs a DC motor. So what we're going to do here is, and actually, Eden, can you show the code
Example.
from last year?
Yeah.
Oh, quick. So there's a class from the WPI library called DC motor, and it has a whole bunch of functions that we can call for getting specific kinds of motors. So in this case last year, we were trying to simulate a Neo 550. In our case this year, for this workshop, we're going to want to simulate a Victor SPX or a Victor SP. So we can go back to VS Code.
Wrong one. How do we get out of here, guys? There we go.
Okay.
It's not letting me switch.
You are probably on the wrong monitor right now.
Yeah.
Okay.
Set
So instead of null, we're going to want to type DC motor.
Cedric, you should come over here. It's popping up on there, but not on here. It won't let me switch. No. It's we need to be in. We're in the wrong. It won't let me go. If we click the drive out of sim, we'll run the wrong tab of VS Code.
Yep.
We need to be in this one.
What Chrome? I just go Chrome. Drop this.
Oh. Thanks.
And then just go
I don't
to
know
the
this
other
yet.
side. DC.
I disagree.
Thank you.
Front, left,
Okay.
back, right,
DC
front,
motor.
back, right.
Okay,
Alright.
guys, we're back.
We're going to do DC motor dot, and then there should be a function here called something like get Victor. No, of course there's not.
Well, is Victor SP the motor controller or the motor?
You're right. That is the motor controller, not the motor. Does anyone know what kind of motors we use?
Can we look this up?
Those are not Neos.
Victor FDX.
They are old.
Someone type in 1217-3.
I think that's the part number.
All right. So the kind of motor that we're using on this robot is fairly old. I'll just give you guys the answer. It is a sim motor. So get sim is what we want.
Right. No, it's a sim for a sim.
Computer operated manufacturing.
I don't know what this
That's so
stands for. All right. Gearing is the gear ratio between the output of the motor and the actual wheel itself. I don't know what the gear ratio is. So we're gonna do something close to what we have in our other code. I think the other one was like 6.25 or something like that.
Out of control.
6.75. We'll put 6.75, and actually, we'll just copy both of these two parameters here. All right. So for the next two parameters, we're going to say 6.75 and 0.025. They're probably not technically correct, but this is a simulation, so it'll be fine.
Is the parameter for get sim 0?
Yeah, because it's essentially the number we assign to the motor. So it'll be 0, 1, 2, 3.
Okay, thank you.
Hold on.
Wait, it won't?
Nope. Go ahead and hover over get sim.
So it's the number of motors. in the
Oh.
box. That's why I was confused.
Gotcha.
Yep. So it's not 0, it's 1.
Because it said num motors, and I'm like, if that's the number of the motor, that should not be plural.
Huh?
Variable names.
They want you to delete 6.75.
Why?
It says syntax error including 6.75 deletes token.
Don't do that.
Yeah.
Don't do that.
Put a comma between your get sim.
Oh no, my froze.
You can share that or something.
Okay, I
Make it
don't-
on freeze.
No.
I just had to wait a second. Okay, have fun. I know, right?
What? This thing is
I did it.
Because
But how are you getting all not error? I have like 8 errors currently.
Semicolon.
why do you want me to look at your code?
No, it's just the DC motor sim and the DC motor drive motor sim are just yelling at me about
So, how do I get this?
I'm gonna look at what it's.
Did you use the semicolon?
Yes, I used to.
Did you use a 3-prong semicolon or a
Yeah,
4-prong
just yelling
semicolon?
about that. And I have.
And so it's not drive motor sim, it's DC motor sim.
The joke about the 3-prong is you
And then, do you see how you're missing an import line?
Oh, yeah.
That's why it's looking bad. When I typed in DC motor sim, once I hit enter, it automatically popped up the import for me. So I don't know why it didn't do that for you. Is there a setting that he needs to change? So I'm not, when I typed in DC motor sim and like hit space, it was like, here's that import line that you need. I'm just gonna put it in here for you.
Oh,
And
we
he was missing the import line. And I don't think he deleted it, because he didn't say, oh, I did.
It is possible that the Java language server needs cleaning. It's also possible that the WPI lib might just be having trouble finding it. The one thing we can try is getting rid of all the syntax errors, like actually fixing them, and then building, just to see if we can get a successful build.
He just imported it and all the obvious errors went away. Should we try to build it just to see what happens?
Yeah, let's do that.
Go to Microsoft or whatever. Go to
It happened again.
Gradle thing?
It's not happening with me.
Okay, you need another, so you don't have Gradle/wrapper. So we're gonna make a new, can you let's go do that and make a folder with one wrapper? And enter. And I wonder if you could just drag those files into.
Oh, wait, so they're all the same.
Try that.
What? above.
How do I do
Nope,
this?
look, don't click
Uh,
just the
what
two
is
files.
So
Click and drag those to the back.
violation, look into what I have.
What do you have in the
Yeah, I got
Natural.
And then do that for the other one as well. And then,
Give me I'm giving you $5. It started to not look like a word.
You are also missing your input.
It's not.
and then if you move this to the side of it.
I didn't want to
What?
drink more than 2 paper
Should I-
towels.
think it's
And I would do the bathroom.
And then just drag it into
No, we're not.
No, I don't.
Wait until the ball's done,
And then if you want to start copying stuff, we can go back to. Okay, let's lower this down a bit. Oops. Okay. Oops. So, Carlos, we started around here today. So just all the stuff that's in Drive here. Yep. If I own Drive, I have so it's like all the Drive stuff should be right there.
Okay. Raise your hand if you're good to move on.
Ah, that was
Oh, I know that.
Okay.
She's missing her input.
so just all the stuff that's right there. Except for the word Drive. So you know, stuff that's inside of that person. It's currently not in the picture. That's the stuff that you put in there.
I'll pull it up once. Is that okay?
I can just walk you through it. So create a new tool.
Usually if you have a ticket going on,
So just double
this little thing
Towards
here.
left click.
So you can do that for PC person, also you can do that for
Space equals Drive plus 15.
Save the file.
And she's still cleaning the word out.
And then just the same thing, but Drive minus rotate for right.
Yeah.
I don't understand. But it looks cool.
Yeah.
This is all stuff like
Yeah, but
that.
it takes AP
And so then,
CSA.
hey, doesn't keep us in advertising for your class.
It's A, I hope you like Java. You're more than a lawyer. Good D.
That's the other one.
Taking it to the Python level base.
Fair enough.
Hey, Colin. Should we keep going? Okay, guys, let's listen up. We're gonna keep on going. Okay. So if you guys will recall, we have this done. Do we need to simulate anything else? Do we have any other hardware on this robot? Yes. So we need to simulate the gyro. So how do we think we should start this if it's hardware?
Private. Final.
And then gyro.
Gyro sim.
It's like a 80 XRS 450
80.
underscore gyro sim.
This one?
80x
Or this one?
430 gyro
80
sim.
XRS.
80X RS.
450 gyro sim.
There we go. Okay.
Gyro sim.
Then we can call it gyro sim equals new. And it once.
Was there were two versions of the constructor.
There were.
Yeah, delete the or yeah. And then open parentheses. Simply. Okay, it looks like it is going to make a gyro in there. So in here, it's saying in order to simulate a gyro, we need to actually have a real gyro, which is fine. The WPI library will let you make a real gyro so that we can simulate it.
So what we're going to do is inside the parentheses for this ADXRS 450 gyro sim, we're going to say we're going to create a new ADXRS 450 gyro. So the ADXRS 450 gyro, that is the type of gyro that we used in our hardware class, in the Drive.io Victor SP class. Does everyone remember how we created a new gyro in that class?
I can look.
How do I make a new object?
New.
Yeah.
What is the object they're
So
creating?
ADXRS
Sim.
450 underscore gyro.
Yep. So that's the name of the
Whatever we
class,
wanna
and we
name
need
it.
new at the beginning, and then the parentheses after that. Parentheses.
My bad.
Okay.
So we're putting an object in our constructor.
Yep.
And that object is being constructed.
To be simulated.
Yeah.
Huh.
Okay, that's a bit confusing. That's okay. So if we go back to the example that we have, you'll notice that we have something here called volts. Considering that it implements the intake IO, and we can go back and see that IO really quick. Maybe. We're not going to go back. Wait, actually, I'll just go to intake. Okay. Considering our this class and the fact that we have member variables for the intake sim class, what do we think the reason for that is? I think I worded that badly, but why do we think that we have a volts member variable in our intake sim class?
Because we want to be able to simulate what the volts are.
Yes, exactly.
How?
So if we go back to our class, we can see that we, at any point, do we do something similar?
Wait. We have angle. We got speeds.
Is this showing at the same way? Okay. Yeah.
It's showing sim, yeah.
Yes. So we have a double volt here, and essentially that sets the voltage. So we are going to want to have a member variable in our sim class, similar to the other one, to simulate our voltage for those motors. Does that make sense to everyone?
So if we have it, we should simulate it.
Yeah. So let me draw this out really quick. That might help. So
Make sure the camera can see you.
Okay.
Yeah, I'm good.
Okay. So
I'm not doing anything.
I think the wrong way.
I was going to say I don't want to point at you.
Yeah. Okay. So we have, let's say, in our IO class, we have all of our hardware, and we have some different variables for them,
Hey, Cedric, I can't hear you then.
and we have some different methods and stuff. And for some of these methods, we need parameters to do stuff, like voltage and stuff, and that kind of thing. And we want to, when we simulate, we want to have the simulated class as accurate to the real thing as possible. So when we create our hardware, we're going to do that same thing. We're going to have our variables as well. But in order to interact with them like we would with our methods right here, we would also have to create member variables and similar things to that so that we can use these methods in our simulated class. So we were essentially creating the exact same thing, but we're doing it all simulated. Does that make sense to everyone?
I heard it kind of from Ethan, so I'll take a stab at maybe explaining it a little bit differently. So the whole point of the sim class is to simulate the hardware that we're interacting with. And one of the things that we need to do in our IO sim class is we need to be able to ask the motors, hey, what voltage are you currently driving at? The DC motor sim object does not have a method that allows us to actually ask it, hey, what voltage are you currently driving at? So what we're going to be doing is anytime we set the voltage, we're going to keep track of that so that the next time they ask, hey, what voltage are you currently driving at? We can say, oh, this was the last value you told me to drive at. So that's what I'm doing. So our member variable is just us keeping track of what the last commanded value was so that when we go and ask it later, hey, what voltage are you driving at? We can tell it, here's the last thing you told me.
Does anyone have any questions on that, or does that not make sense? Okay, so we're gonna do that. Yeah. Do you have a question? Okay, perfect. So we're gonna create that volts variable now. So when we're creating a member variable, what's our access for that?
Private.
Exactly. So we're gonna do private, and what's the data type for volts?
Double.
So we're gonna do, and then we'll name it volts. Perfect. So we have this, and
So we will need a left volts and a right volts.
gotcha.
Private left volts.
Mhm.
And then let's make the right volts public. No. Right volts.
A general rule of thumb for your access modifiers is you want things to be as restrictive as possible. If something doesn't need access to one of your attributes, you don't want it to have access to that attribute.
Okay, perfect. Does everyone have these two lines? Does anyone have questions about those? Perfect. Okay. Do we want to take a short break, or do you want to keep on going?
We're super close to being done with this class. Let's finish this class and then we'll take a break.
Perfect. So let's go, and we're just going to take a quick look on everything else because it might be hard to guess what exactly if it'll work with me. Perfect. Okay. So notice here how we have our update input method with our method that is created in the other intake IO. So first things first, we can copy and paste this, or you can type it out. Some things are going to change, but we're going to create this, copy and paste this update inputs method because that's kind of what is going to update our inputs for the variables. So we're going to do the other curly brace, and yeah, so we're not going to do intake IO. It's going to be drive IO inputs. Okay. And this is going to take in all of our inputs and update them. Similar to what we had in our, not drive, it is hardware class. So something kind of like this, but not exactly. Does everyone have this so far?
Give them a second to type.
Yep.
They didn't just copy and paste them.
My bad. Yeah, my bad.
Curly braces. But inside the class itself. Inside the drive IO sim class.
Them being right is not them wrong.
Yes. You're not in that file. So yeah.
Yeah.
Technically, yes.
Oh, we did square brackets.
So now we're going to work on updating these inputs because when we have these variables, are they getting updated?
No.
They're
We're
just
just-
kind of sitting there.
Yeah, what's up?
Oh wait, I forgot what it's called.
Okay, that's okay. What? Kind of, yeah. So it's those when we have a periodic method, it's typically called exactly periodic, but it does kind of something similar. It continuously updates it. This is kind of something for Advantage Kit, whereas periodic is something kind of general to everything. But so you're exactly right. Now we have to update these continuously. So if I recall right, I'm looking at Colin. We just call the method updates, right?
Yeah, I forget exactly what it is. I think it's FR motor sim update.
FR motorsim.update. Perfect. That's really easy.
It wants the amount of time that has passed in seconds. Does everyone remember how quickly our periodic runs?
20 milliseconds.
So that would be 0.02.
My bad, guys. Okay, so this continuously updates our robot and updates it every 20 milliseconds using the values. So we're gonna do the same exact thing for all of our motors. So we're gonna do update 0.02. Motor sim update 0.02. Motor sim update 0.02.
Well, we need to do the same thing with the gyro.
Okay. Comments.
Amazing.
Motor sim update.
Looks like we're done YouTube. Perfect. Yeah. Don't worry about updating the gyro. Okay, so these lines here, these really just tell the motor simulation how to continue to move the motor. But what we're interested in is, in this update inputs method, is we need to update all of our inputs. So we've got that inputs parameter. After we tell all of the simulation logic, hey, it's time to iterate over the next 20 milliseconds, now we need to go tell our inputs, here's what your values are. So I'll give you the first line for free. It's inputs dot and then do FL wheel speed equals, and then what do we think our FL wheel speed is going to be?
Think about what we already created in this class.
Volts is half, right?
Is it FL motors then?
So what's the data type of FL wheel speed?
That's a great question.
Double.
Yep, it's a double. So as Eden's hovering over there, we can see the second to bottom line. It says that this is a double.
Oh, that's nice.
So this means that whatever we assign to it also has to be a double. So we won't assign the motor sim because that's not a double, that's a motor sim.
Mm-hmm.
What about the left volts and right volts in the same way we did it in the
Drive.
the drive?
So if FL wheel speed is the variable we're assigning to, do we want left volts or right volts?
Left.
Left volts.
I was like, is this a trick question?
No.
We want both volts equally.
So right speed will be right volts.
But if you have a charger, you're
gonna die?
Be able to load charge it.
Okay, yes, I do.
What percent charge?
I know, I wasn't looking at it.
It's at 10%.
It's low.
What would you do?
Okay. So those are our inputs for our wheel speeds. We have one more input, right? And that was for our robot input. So our robot angle, that's measured by our gyro. So we need to ask our gyro, hey, what's our current angle? We can say underscore gyro sim dot, I think it's, yeah.
Get it? We didn't. Anything.
Okay, gyro sim dot, what are the numbers we have here?
They're limited.
That's implied. All right, so I think what the WPI library wants us to do is it wants us to have one variable for the actual gyro itself and then one variable for the sim class. So here's the neat thing, the sim class object, we actually have to tell it what its new rank was every time we go through a normal 20 millisecond period. That's a lot of overkill for right now, so we're just gonna always say underline is 0.
No.
We're gonna simulate.
Being lazy?
Yeah, a little bit. We can think about it this way: we are simulating our robot being up on blocks, so the wheels aren't touching the ground.
Okay.
You do.
That doesn't seem like a very useful simulation.
I think
Unless we're trying to
Well-
simulate whether it'll spontaneously combust.
we'll be able to see what the motors themselves are actually doing. Let's. So I've got the other 3 methods.
Yeah.
We'll do those then.
Yeah. I'm just saying, are we good to move on?
Yeah.
Okay.
Josh,
So,
Yeah.
now that we have all the stuff done with our variables and those kind of things, we initialize them. Now we're kind of going to work with our methods, which are responsible for actually interacting and doing the actions that we want to work with. So if we go back to our class over here, we have 3 methods that we are going to use. So we're going to do something similar to those. And if you want, we can look at an example about this what it look like. So we don't name it set volts like sim or anything. We just name it set volts, and we're going to update it with the simulated hardware and do that. Does that make sense to everyone?
The methods that we're calling are the methods that we've outlined inside the Drive.io interface.
Yeah. We're just assigning the values, but with simulation rather than using the actual hardware.
So get out of the update inputs method.
Yep, we're all done in there.
So this time we're going to create, so we're going to do first, we're going to do our power left. So we're going to go back over here. What would be our accessor?
Public.
Public,
Void,
void.
or left, but I thought there was another word in there maybe.
So
Default.
this at default, we don't need default here because we're not providing a default implementation. We're providing the actual implementation. We do need the at override too. And if we haven't added it, we'll need that on our update inputs as well.
Yeah.
Oh, we have it. Perfect.
So power left, and in order, we have this left volts right here, but does this have a value? It's just a space in the computer, so we have to actually give it a value. So we're gonna have some parameters for this value. So we're gonna do double left volts, and then when we go down here, we can call the method we created at the top. We're gonna do left volts. That's gonna equal left volts. So basically, this is saying that we're gonna take the left volt space that we created, and we're gonna assign it to the parameter here so that when it gets inserted into the method and used, it will actually produce a value. Does that make sense to everyone?
So
Yeah.
the underscore is that's our copy of the variable, and the left volts without the underscore, that is whoever called this function gave us.
Remember the this keyword?
Yes.
Kind of like that,
Exactly.
but without this.
Okay.
If we didn't have the underscore, we would have to put this.
Okay. So now that we have that, we actually have to use it with the motors. So we're gonna call the motors. We can start with our FL dot. And what do we think we might use for the method? This is how you do it, right?
Yep.
Cool. Set, and then what might we be able to do here? Yeah, exactly. So we're gonna set. Wait, what did we set for the sims?
Set input voltage.
Okay. Oh yeah,
Right one.
I think so. Yeah. So it would set the voltage for the DC motor using the volts. So it would use this parameter and set the voltage for that. Yes, we
Yes.
would.
We literally talked about setters today. In class.
Yeah. I'm getting tons of practice.
You are.
Okay. And after this, what do we have to do?
Same thing, but on the right.
Exactly. So we'll give you some time to get this done, but we're gonna for the right side.
Do the override thing.
Yep, we will. So we're gonna do public void power.
So at override says, you remember how up at the top we said our drive.io sim implements drive.io. Drive.io has a version of the power left and power right methods, right? And those are the versions that have the default keyword in the name of the function, and there was no content to those methods. At override says, hey, anything that I'm extending or implementing, if it has a method with the same name and someone wants to call that method, they're not allowed to call that version. They have to call my version, the one that I'm writing right now. So if we didn't have this at override and someone had a drive.io sim and they wanted to call power right, what they would get is the default version that doesn't do anything because we're not overriding it.
What could we not write this decided? Right?
So we can't write this inside of the Drive.io interface because the Drive.io interface is common between the sim class and the Victor SP class and the implementations that we need for those two classes are different.
Great question.
All right, now we have one more method in the Drive.io interface, and that was our reset gyro method. Who remembers what the reset gyro method is supposed to do? It sets our gyro to 0. But do we remember what I said earlier about our gyro in our simulation? It's always going to be 0 anyway. So because of that, we don't really have to do anything inside that function. And because we don't have to do anything inside that function, we don't have to actually write it here. Now, normally when you have an interface, you have to implement all of the functions that are defined inside that interface. But because we have that default keyword in there that says, hey, if someone hasn't implemented this method, you're going to use this default implementation that does nothing, which is exactly what we want. So we're just going to not define that function.
So does anyone have any questions about this so far? You confused about anything? Need help with anything? Okay. I think we might take a short little break before we move on because this concludes our Drive subsystem as a whole. You guys made a whole entire subsystem. Good job. Okay. So there's food in the kitchen. You take a bathroom break if you need to. Just chill out. We'll be good. If you need help, let us know.
This is the end of day 3, part 1. We'll see you in day 3, part 2.
We'll take 10 minutes here.
Gyro.
Not me, not knowing how to turn on the recording. There we go.